All right. Hopefully I can be heard okay. So let's see, what am I going to do today? Well, I've got a Lynx Model 1 here that I've already got partially disassembled, as you can tell. And what I am going to do, basically what's going to be done is we're going to completely replace all the capacitors in it. And I'm also going to be replacing all of the power stage components as well. And all of that's being done to prepare it for a final modification or upgrade of the LCD screen itself. So what I'm going to do in this video is I'm going to go ahead and get the LCD screen portion removed and get the capacitors replaced in the power stage components. So yeah, since I've already got part of the LCD already semi undone here, I think I'll just go ahead and finish up the process. I've got a small set of ribbon cable. I've got a small ribbon cable set here that needs to be undone, which can't be seen based on the current angle that we're looking at, but that's okay. So the way I'm going to do that is I'm just going to hit it up with some heat and start to pull it loose. There we go. Alrighty, there's that part. Get my solder wick to clean these pads up a little bit more. Okay, looking pretty good. Clean that off a little bit. Let's see, there's a part of a Q-tip I can use. Just realized that my counter lights may be making that a little too bright. Okay. I'm going to get these ground portions here of this foil. Get my tweezers for this. There's a lot of solder used on that. Okay. There's another one down here on this corner. That should allow the screen to just about fold down flat. All right. Let's get these screws off the diffuser. Although I don't really need that. They can actually stay on there. I'm okay with that. Got two more screws so I can get the reflector plate off. It's also wrapped around the light tubes connections. So let's get those out of there. There we are. Collector and light tube off of there. Just going to set those off to the side somewhere. Okay, because I'm already here, it's already warmed up. Let's get rid of this excess solder. Actually, some plastic on that, or foil rather. I need more heat. Okay. That really sticks on there. All right. Now to get the rest of this screen off of here, let's see if it's adhered at the base at all, and it is, just a little bit. I don't just want to peel it right off of here, because what will happen, or what could happen, is you could take traces off, and we don't want to do that. Also got to get these off of here. Okay. Let's get this up to the adhesive, off of the adhesive line at least. There we go. I think it's just a piece of double-sided tape. It's what they originally used to hold the ribbon cable down during the assembly process. Okay, there we go. We got it all off of that. And then I'm just going to use my soldering iron, start applying some heat, and get the pins off of here. Okay. Not bad. Obviously it can't be reused again, but I don't know. It might be possible if you really, really wanted to. Okay, old LCD has been removed. And that's where the old double-sided tape is. I'm going to go ahead and hit this up with a lot of alcohol. See if I can scrape that off of there. Nope. Still doesn't want to quite come off. I was hoping I could just grab it with my fingers and just start peeling it away, but that's not going to happen. So I'm going to have to use this fairly sharp flat blade screwdriver I actually use for scraping away at the solder mask when I need to expose more traces to solder something to or what have you. So I'm just working my way down slowly with this to try to get this old double-sided sticky tape off of here. I guess it doesn't have to be removed, but I'm not a fan of it. I'd like it to be off of there if I can. So I might need some more alcohol in there. Usually alcohol gets the stuff off of here pretty well, but this is being kind of problematic. Turns into like a slimy gel. There we go. Still some residue behind, which I think I can get some more alcohol and Q-tip. It's just a slimy mess. I keep a lot of old t-shirts around for cleaning up stuff like this. It's doing a far better job of getting that old sticky tape off of there. All right. Much better. Okay. Now what I need to do is clean these pads off. And the easiest way to do that is just to use some flux to go across them. And my desolder wick. Well, that's not good. We have some pads coming off of here. Luckily, they're not pads that we care about. Not yet, anyway. I don't start getting to the pads that we care about until we have to go down about to the 9th pad or so. I think that happened because my iron was just simply too hot. I've turned it down to about, we're about 325 C right now on the iron, which is pretty typical to where I do most of my work from, temperature-wise on the iron. But I had it hotter than that earlier, trying to get those copper sheets off that were acting as grounds over the LCD panel. So yeah. For any that are curious, yes, this is warm, but not so much that really feel like I'm burning my fingers or anything, so I'm okay. Okay. It's much better. These first few pads are a little damaged, but that's okay. We won't need them. All right, let's clean this back up again. Get a fresh Q-tip. Okay. Also, those two pads that did get taken off of the PCB board, if for some reason somebody wanted to install an original screen or another screen later on or whatever, if it actually needed some of those two pads, there's two attachment points right up here. They're easy enough to solder onto. Some vias right there on the board. Okay, so it's cleaned up about as well as we can get it right now, and now we can proceed with replacing the capacitors. Or maybe I'll replace the power stage components first. Let me look here and see. Because what needs to be replaced in the power stage are, we have to replace Q13, Q4. I have to replace the original Zener diode here. And then we have the main power MOSFET here that will have to be removed. Yep. Okay. And then the easiest way for me to do that is I actually have a hot air station here that I'm going to get started. Crank it up. let's see. I don't think these fuses have to come out as part of this install. I guess I'm not too worried about them. I will go ahead and remove the main power board though, because we won't need that anymore. Ah, 2 solder points. Oops. Slipped on me. That last one might need to be done again. I tell you, these Lynx ones have huge planes on them that act as ground and power throughout the whole system, and I really have to turn the iron up more to penetrate, or to get the heat to not... There we go. Okay. It still doesn't want to come loose. All right, I'll do it by hand. Okay. It's the main voltage input line. All right, so got the power board off of there. Set that off somewhere off to the side as well. All right, now guess we'll get started on these caps. Let's see, how do I want to start? I guess I'll just start from here, and oh, would you look at that? Another one of the Lynx's most common problems is the power port. They're just horrible. This actually looks like it has a replacement on it already. Wow. Okay. Now, the reality is the legs that used to be attached to that just went up into my iron, so I need to make sure it's cleared out. It's no fun drilling out your soldering iron or your desoldering iron. Okay. Well, the vias look good there, but yeah, this power port. Yeah, it's been replaced once before. It's the same type as what you get from console 5, but the legs are just gone. Well, that was actually going to be replaced anyway as part of the what we're doing here, but I didn't expect the original to just fall off like that. But this is also one of the reasons why when you replace them, you need to make sure that you use some hot glue around the edges of it to hold it into place. Little solder blobs that are just sitting on the back of this board. I have to guess somebody else has been inside this besides me. All right, let's get the replacement power jack in place. Just hold it there for a second. And what I will do on this, or at least what I normally do, turn the heat back down again. Don't want to melt these leads off of here, these legs. Just going to get the center one first. And then I will hold it, get it straight. Like that. And get the others on. Okay. Now we'll start with the capacitors. All right, I need a Sharpie. Negative. So I'm just going through and I'm just marking the polarity. Specifically what I usually do is I put a little silver dot next to the negative lead on my capacitors. Now, the reality is the Lynx and a lot of other classic consoles will also have marks on the top of the PCB indicating where the positive lead goes, which of course helps to, helps assist in doing exactly what I'm doing right now. But I just kind of go a little step further. All right, we got some of this double-sided tape. I need to hold on to that, so I'm going to stick that off on some stuff here. Okay, that's not blocking anything I care about there. And all these capacitors here were kind of laying down in a very specific way to keep them low profile, so I'll try to replicate that. All right, that takes care of the capacitors on that side of the board for now. That's enough to get started. So what I'll do now is I will start putting fresh solder onto the legs of these to make it easier to remove them. The easiest way to remove a component and to remove the solder from it is to add solder first. Yeah, see? Large ground planes. Wait for the iron to get to temperature. Okay. I could just push one of the legs out while applying the solder. Okay. I think that's got most of those. Let's remove them. Now, even though I've hit them all up with some solder to get them ready for this, I'm still going to remove them and replace them out one at a time just to keep track. Okay. I should have opened up the replacement capacitor bag. All right, so first thing I need is 50 volt, 1 microfarad. Let's get these lined out a little better. 1025. It's the 220. 100. 1025. 1025. I usually end up with some extras, which is nice because I can use them in other things. It's nice when I get extras because I have also, on occasion, it's rare, but on occasion, these are 10 microfarad, 35 volts. Interesting, okay. I've also ended up with 1 or 2 short of what I'm supposed to have. Of course, that doesn't work out very well, does it? These are my 150s right here. These are. So you can see that we've got tiny, the replacement capacitors in this case are smaller than the one I just removed. Yep. Not a problem. But it also means I'm going to have to reform the leads so that they fit properly through the PCB. This can be a time-consuming process. And I'm bending the leads up like this, not only so it'll help to fit more flush against the PCB itself, but also it provides a little less stress on the legs or the leads of the capacitor once it's in there. So on this one, because it's so small, I can actually get to the vias on the top. So what I'm going to do is I'm just going to apply a little bit of solder to hold it in place, like that. Now I can finish up. In fact, that one already went all the way through. That one's good. Here. Just a tiny bit more for good measure. Snip them off. Go. That one's done. Next one. This is a big guy. Okay. 135 volts. Okay. One that's like the only big one I have here. I think it's this one right here. Yep, 135. And I will need to reform the legs on this one. Actually, what I will do with this one, to help it fit inside the case a little bit, The original one had sort of a twist on it a little bit. They had angled it a little bit, and I'm going to do the same thing on this one. There's my negative. So we're going to bring that lead down like that. And pretty much just like that. There's just not a ton of room in the case where this large capacitor goes. So it'll be easier to just turn it to the side like that. Okay. My iron is at a pretty hot temperature right now. It's sitting at about 400, so that I can more quickly get the solder to adhere to these large planes for power and ground on this board. It's just ridiculous on the Lynx 1 how thick they are. Makes it more difficult for anything to want to stick to them. Case in point, that capacitor. Okay. Finally got that off of there. 47010. Okay. 47010. That's going to be the other slightly big one. It's over here. Here it is. Okay. Need to reform the lead on one side. Not both sides like the smaller one, but just one side is enough on this one. Screwdriver out of my way. Okay. This one's tall enough, it'll just stand where I need it to when I go to solder it in. Okay. Apologize if it gets suddenly noisy. That's my air conditioner kicking in. Never fun. Always loud. 1035. 10 microfarad 35. That's not you. That's this one. I'll be able to get away with just having to reform one of the leads on this one and not both. Yep. It's pretty much exactly where it needs to be. All right. Another 1035. So I already know where the other one goes. Yeah, I know I said I was going to replace the power components first, didn't I? And I didn't do that. Well, I will. Luckily, nothing's really in the way to prevent it from being easy to do that. So on the Lynx 2, I kind of have to get some of the larger capacitors out of the way first near the power stage before I can really do it easily. Or properly, I should say. Okay, what is this one? This is the 10 6.3. It's these little guys. Nope, that's 47. That's 2.2. Was that again? 10 6.3. Okay. I think console 5 has just decided that maybe these little 1025s will do the job, and they will. They'll do the job. It's overkill on the voltage, but it'll work. All right. It will make it more difficult to get it to sit down the way I need to. On this one, I have to bend both of the leads. Initially flush, then make sure it's the right distance. It is. And then last but not least, I want to make sure that it sits flat back down again like it did before. To do that, I'll have to bend the leads again, like that. Okay, that is sticking up way further than I expected. I can probably just bend those leads out a little bit and it'll probably stay pretty much where I need it to. Let's see how bad we are. Well, we're not too bad. We're not where I want to be, but we're not too bad. So that'll work. It's almost time for me to get another set of flush cutters. I'm starting to see light creep through a little bit where I can see they've started to dimple in on the cutter, on the blade a little bit. That happens when I cut leads that are way too thick. Okay, let's go ahead and get this little guy. He's right there. Another 10 6.3, which we've already determined I have to use these 1025s the console 5 actually supplied. This one's going to do the same thing. It's just going to fold down flush pretty much to the PCB. So form the leads. Make sure I got the right length. I do. Make sure I lined it up the correct way. I have. Okay. I can already tell this one's going to travel. So I will use handle of these flush cutters for it to rest on. Okay. Works pretty good. Let's see. These are the easy capacitors on the Lynx 1. Because underneath the RF can, right here, there's more capacitors hiding under here, including one that's a real punk because it's basically folded and sits directly underneath the cartridge port. Not fun. And it's a decent sized capacitor to boot. It's not even a small one. So you kind of have to just start to thread it in at an angle, and then you have to pull on the leads as you push in on it, because you really can't preform it to sit it in there. There's just really no way to do it. In fact, you can, I'm not sure I can even get my camera to show this. Probably not. But I'll see what I can do. So you can see the cartridge port right here. Well, the capacitor I'm talking about actually sits right here, and it's folded directly at a 90-degree underneath this side of it here. Sometimes it's also easier to get to it if you go ahead and pop off. I believe this is the volume. Yeah. It's easier if you pop off the volume knob to have a little more room. But you also have to get rid of this copper back that they have on here, and that's because it's got these tabs that it's soldered down to that you also have to lift up to get the can off. So fun, lots of fun. Okay, let's get this next capacitor off of here. This is a fairly large one. Myself out a little bit. Okay. Wasn't the right one. Okay. I had to reapply some new solder onto that capacitor I just soldered on because I accidentally siphoned up some of the solder for it. Okay. It's all right, no big deal. This is, okay, so this is one of the 2.2s. That's these little guys. What was that? 2.2, 63 volts. These are 2.2 at 50 volts. I've seen this on console 5. It actually says that the parts are only need to be 50 volt rated parts, but I guess Atari in their infinite wisdom, it was probably cheaper to use the 63 volt ones. I don't know. Either way, these work just fine. They're also a lot smaller than the originals were, so it'll make it easier to put them in. In fact, I think these might even be able to go straight up without interfering with anything. The originals were sitting over at an angle. I don't think these will be a problem. I think I can put these straight in. So, but I do have to bend the leads down again because they're too close together initially. This might be the first time I've streamed doing this kind of work on YouTube. I'm not sure if it is or not. It's definitely the first time I've streamed using this camera. This is not a new camera. This is the same camera I use for all of my YouTube videos. The difference is that this time around, I figured out a way to use my capture card in combination with my 4K camera to actually stream using my 4K camera. It was power I always had and never knew. Actually, I just never really looked into it, I guess. So much better when that air conditioner doesn't kick in. Okay. I've got a feeling this is the same thing. That's because it is. It wasn't just a feeling, that was an exact, accurate guess. There we go. .2, 63 volt. Means this one here should be the last one, 2.2, 50 volt. Normally, again, you would never replace capacitor with a lower voltage rated capacitor, but according to console 5, they've looked at the docs, and Atari used higher voltage capacitors than what was required. And I'm sitting here thinking to myself, with the inverter removed for the backlight, what on earth could still require even 50 volts of electricity in this thing? Probably nothing. Probably nothing at all now. Uh-oh. Okay. Saying uh-oh because it looked like I was getting my polarity confused there. I couldn't quite tell what went to where. Again, that's why I mark it on the bottom of the board also. That's an uh-oh. Capacitor fell on me. It was sticking in there so nice before. There. There we go. Does that about do it for the easy ones? I think so. Okay, so we've got these changed out. We've got one little one here that I can get to easily. And that's it. The rest of them are all going to be a pain in the neck because they're underneath the metal can. Fun. Fun, fun, fun. Might be about time for a new Sharpie. Again, large planes of traces or large traces with lots of metal in them take a lot more heat. This one's being a little more difficult. Here we go. Had to apply a little more heat to it to get it to... Also had to be careful I didn't melt the rubber grommet that was holding the old LCD in. Apparently those are still needed for the new screen, so I'm going to leave them in. 10 microfarad, 6.3 volts. Really? So another 1025? Guess so. 10, 6.3. Yep, okay. This one can stand straight up because apparently there's plenty of room in that area to do that. No, that's going to fall. It's okay. I'll just have to hit it with some heat on one side. Get just a little bit on there. Yep, fell a bunch. Push it up through, flush. Here we are. All right, let's get prepared for a few other things I know I'm going to have to do. Okay. There's a lot of old flux residue on the old cartridge port from when the factory did this. So let's get that off of there. Or at least try to clean it up a little bit. Reality is it's been on there for so long, it's just kind of hardened. It's better. It's not perfect, but it's better. Okay, the rest of this is going to be fun because we got to take the RF shield off of this thing. All right, easiest way to do that will be to just start removing solder. Okay, probably going to turn the temperature up a little bit. It's still not 100%. I'm going to have to get up under here and try to get these tabs pried loose. There's one. Okay. That's two. Now, for some reason, the solder doesn't seem to stick to this flat-bladed screwdriver, which is a good thing, because I need it to help me get under this stuff and get it wedged out of the way. Ah. This one's really clamped down good. Not really able to get anything under it because it's really flush with the board. Okay. Almost. I just realized my head's probably getting in the way now, huh? Probably. There we go. Get it lifted up. There we go. Okay. That took some doing, but I got it broke free. Get that out of the way. Okay, it will almost come loose. This will probably just slide forward once I've got it hot enough. Yep, just like that. Okay. Let's see, I have... Ooh. There we go. That helps. Okay. We finally have the RF can removed, and now what I'm going to do is reform these tabs a little more straight. So it's a little easier to slide it back on top of it afterwards. Is this critical? Probably not, but I'm going to put it back on just because it was there to begin with. Okay, so like I said before, we have a few more capacitors. We've got two more right here. Two more sitting right here. Got another one by itself up here, and then we've got that other one I mentioned that sits underneath the cartridge port. That's absolutely no fun to get to. Nope. And then again, due to the RF shielding that sits over this, and it has to sit, I have to sit these down as flat as I can. So, yeah. Go ahead and get these reformed and straightened back up. Okay, where's the negative on this one? It's okay, we got to get this. Now the next thing I got to do is get this copper plate off. Which I'd already loosened up largely when I got those other parts off. Okay, so all we got to do now is get my tweezers under here, get this part hot. Just like that. And it's got some double-sided sticky tape, it looks like, holding it down. Yeah, because my tweezers are stuck to it. There we go. All right, now I can get to those capacitors. But before I do that, since I'm already here, I'm just gonna make the original solder that the copper plate was attached to a little nicer. Get some old debris off of there. Clean it up. It's actually part of a plastic coating. That sits on that is what that is. Just helps whenever I'm ready to reattach it to have a little nice fresh shiny coat of solder for it to attach to. Okay. Solder or sticker? And it's just some gunk. Okay, gunk. Clean those up a little bit. Can't tell if that's part of that plastic. That's what that is. That's more of that plastic stuff. There. That's much better. Okay. All right. Now, let's get those capacitors off. This one and this one. Okay. That big one, it's hiding under there. And it is right there, I believe. Okay. Let's get some fresh solder on those. Stupid copper plate getting in the way. All right. And 6.3, so it's going to be another one of these 6 or 1025s, is that right? What it is? 10, yep, 10 microfarad, 6.3. So that'll be the last of my 1025s that goes in there. Needs to sit flat. Wonder if I can do it at an angle. Do it like that. May have to do the 90-degree. It's kind of why I decided to do this one first. Okay. Hmm. 150. Haven't seen one of them in a while. I didn't even have to fold this one over because it's a lot smaller. The replacement's a lot smaller than the original. This sitting almost flush is probably about as tiny as I can make that. That's all right. Go ahead and do it the same way. Make sure those are the right length. Yep. Now, let's get it to go flat. Okay. All right. It stayed put and everything. All right. Takes care of those two, and then I got this guy here. This is a 47 microfarad, 6.3. We have a whole batch of those little guys right here that we haven't even used yet. And they're roughly the same size. This one can stand straight up though. Still have to reform the leads. Looks like one of these vias didn't clear out quite well. Okay, so just like that. Of course, it's going to fall right through. Okay. Okay. Now, last capacitor and least fun. It's also difficult to get out of there. Okay, it's loose. Now to try to get it out of there. There we go. This is a... Okay, so this is the 220, which is this one here. They're both the same. Okay. It's basically the same size capacitor. It is, in fact, it's the exact same size. But yeah, it's basically impossible to to just fit it in there normally. So what you pretty much have to do is just kind of start bending the leads kind of at a curl. Because it is absolutely not going to want to go in easily. And then once I've got it started and I can kind of get the leads to the vias, then what I'll do is I'll use my tweezers to get them directly in there. Okay, now start to push it as I pull the leads through. Okay. Okay, so it's sitting in there where it needs to, but what I'm going to do is get it soldered down, and then I will use my tweezers to push down on the capacitor a little further to make it sit as flush as I can with the board underneath the cartridge slot. Because yeah, like I said, this one's not a tremendous amount of fun to get in there. Okay. Technically it's in there. Now, let's see if we can make it sit a little more flush. The easiest way I've found to do that is just to take the blunt end of my tweezers here and just kind of wedge it in between the capacitor and the edge of the cartridge port. And there we go. And it's in there. Probably can't tell, probably can't see it, but it's in there. We got it. We got it. Okay. Now I have some extra capacitors, which is not unusual. And on these, I will, let's see, what are these? 150s? I usually cut these out to try to keep the leads as long as I can, because I don't know, I might need to use them in something that's going to require a longer reach or something. For the Lynx, it was no big deal. I had, I could just cut them at the base. It's fine. But if I'm going to use these on other things, and I'm sure that I will at some point in time, then I'm going to remove as much of the tape that is holding these in as I can and get them out of there nice and easy. There we go. And then I have a box like this that I keep all these in. All right, let's see here. This is 1-50s. I think this is a box here. I realize you can't see what I see because I'm looking at my capacitor box, but that's okay. It's boring. What are these? The 4763s. So I had a whole bunch of these left. These are actually sticking up high enough that I feel confident to just cut these straight off the board or off the cardstock that they're taped to. Okay. Now, let's put these in my little box where they go. Okay, that gets the extra capacitors out of the way. Excellent, now what? Okay, so now we are ready to get these power components replaced. And that is a little more interesting. Okay, so the easiest way to do this is to, first I'm going to clean up these pads where the speaker's attached with some fresh solder. Okay. So I think I'll start with a MOSFET first because it's huge. It's this big giant thing right here that's got to come off the board, and this is a surface mount component. So I'm going to use my hot air station to try and remove this. Now, another way to do this, if you don't have a hot air station, and you got to be very careful with this, but this can also work. You get your flush cutters, and you need some really sharp ones. And what you can do is you can snip the leg right where it meets with the package, the plastic package up here. And just be very careful when you do it. Don't go fast, go kind of slow, because you don't want this to rip off of the pad or to take the pad with it. So it's not the most recommended way, but that is a way that you could get this off. So once you had these legs cut, then you could use your tweezers, which I just seem to have misplaced mine. Where were they? There they are. Then you could use the tweezers to hold on to the remaining parts of the legs while you used your soldering iron to lift them off. And then you would hold on to the rest of the package using your soldering iron to remove the rest of it off of there. That's the basic of it. Now, same as before, what I will do is I will add some solder. Has this been replaced before? I can't tell. So I'm adding some solder to this just to make it a little easier. This may have been replaced before, actually. That's all right. We're going to replace it again because I don't know its history. So I added solder to it, and I'm going to get my tweezers. Let's see. I'm going to use my other ones here. These are a little sharper. Like that. and I can really grip onto them well. Get my hot air station out. Wait for it to get to temperature. And let's see what I'm going to turn the air up to. I don't know, maybe about 3. Oh, that's something else I usually do also. I also add a little bit of flux to this. Add some fresh flux to the component to help everything loosen up a little bit. Okay, here we go. 350. All right, let's see if I can remove this off of here and have you guys be able to see it. All right. So I'm just going around in circles with it, up above the component. Okay, I'm starting to get some smoke here that's coming off the flux. Usually what happens when this comes off the board is the whole thing just kind of just eventually just pulls right off loose. Here we go. And then I'll just kind of heat up that old solder to smooth it down. Okay, that takes care of the MOSFET. Nice and cleanly removed. Fun. And of course I have a replacement right here. But I'm going to get the old solder off of there first. Okay. I'm going to need more alcohol. I'll clean up the speaker a little bit since I'm there. Okay, that pad's nice and clean. That's the new MOSFET, and since I'm already here and I'm thinking about it, let's just go ahead and get those little transistors off of there. Just Q13 here, and where's the other one? Oh, it's actually underneath that capacitor that I already installed, so I'm gonna have to get that out of the way temporarily. Right there. Now, the transistors, frequently you can just remove them by using your soldering iron. But I'm still going to probably go ahead and use my hot air station just to make sure. We also have to get that Zener diode replaced, but that's just going to use my standard desoldering iron for that. Okay, We did that a little too quickly. I'll see if I can get these off of here without having to resort to any flux. Yep. No problem. It came right off of there. Once again, we'll clean off the old solder. Okay. Not bad. Clean it up. Almost time for another Q-tip. You can see the flux build up. Yeah, let's get another Q-tip. I want those pads to be shining, almost like mirrors if I can. Awesome. Okay, let's get the old guys out of here. Now, were these components bad? No, they were probably fine, but the MOSFET, the Zener diode, and these little transistors are a high failure item in the Lynx. And considering that the originals are coming up on 30 years of age, at least, it's not a bad idea to go ahead and replace them out, because especially since this belongs to a client, this is not my personal one. I want to make sure that whoever this is going to, if it's not, the client's not going to keep it themselves, then whoever it gets passed on to after that, I don't want them to have to worry about anything. I want it to work for a while, a good long while. And the easiest way to do that is just to replace these components out as a preventive measure. Now, the way I put the new ones on is I just tack down with a little bit of solder on the center pad, and then I grab the replacements. Okay. Once I'm pretty confident that that is in where it needs to go, and it's sitting on there on all of the pads it needs to, fairly flush, I'll go ahead and finish them off. Nice. Let's get the next one ready to go. And yes, they're both the same kind, so it's not, I don't need to keep track of where one was versus the other. They're the same kind, so. Okay. Last part is, of course, the big MOSFET that we took off first. Now we have to replace with a new one. So the way I'm going to do this is I'm going to actually attach the legs on first. Usually I'll start with one leg, then the other, but because this also builds up with heat and it's got a section here of metal, it basically has to sit as flush as it can soldered onto this as kind of a heat sink. So what I'm going to do is put a fresh coat of a very light coat of solder over this whole pad, just like that. And then I'm going to put some fresh solder onto one of these legs. That'll be the one that I use to attach this onto. And then same kind of thing is I'm going to put a light coat. I have to hold this down. It's going to get really hot on me while I do this. Okay. Okay. Again, that's just to help the solder seep underneath it when I go to solder this back into place. Get some flux out again. Okay. And get the new MOSFET ready to attach, which is still very hot. Yes, it is. All right, I'm going to flip this thing around first. Be a little easier this way. You probably won't be able to see it. I apologize, but get this lined up where I need it. Okay. That leg is now held in place. Now what I'm going to do is I'm going to put a whole bunch of solder around it, around the larger section of it anyway. And while I'm hitting it with that heat, I'm going to be pushing down on it at the same time. There we go. And I can see the flux bubbling around the bottom edges, so I know that it's gotten under there. All right. Put my safety cap back on these tweezers. They are rather sharp. Much sharper than these. These are just some little blunt, generic ones, but they do the job for most things. But for this stuff, for the surface mount, I like to use the other one. Get a bunch of alcohol on that and clean it up. Because again, I used a lot of flux around that. So I want to try to remove as much of that as I can. It's just touching up a little bit of the solder from one of those transistors I put on. It was looking a little, not looking as clean as I would have liked. So just hitting it up a little bit more. Okay. Last thing is the Zener. The Zener diode. All right. Oh, yeah. Move this capacitor back where it goes. Yeah. Okay. Zener looks a lot like a resistor, or at least the one that they have installed looks a lot like a resistor, but it is not. There we go. An old Zener diode. And then I'm going to replace it with this one here. Now, the diode has to go in a very specific direction with the cathode, which is the black banded side, facing towards TP19, test point 19. But luckily on the Model 1 Lynx, again, I don't know if this will be, if this can be seen or not, but on the Model 1 Lynx, the silk screen actually shows you where the black band needs to go right there. So it makes it rather easy to get it lined up. So what I'm doing right now is I'm just kind of eyeballing where I need to bend my leads for this. Okay. That should be pretty good right about there. All right. Get that soldered in. Zener diode is usually the most high failure component in the power stage section. If you have a Lynx Model 1 and a Model 2 that do not power on, there's an old trick that they used to talk about, you know, applying power to through the headphone jack, and that's a horrible idea, actually. I don't recommend that. But a similar thing that you can do, and this is a little safer. For starters, we have these nice wire leads that I desoldered off of the battery terminals. Well, the battery terminals are still providing 9 volts. So even if you attach like a bench power supply and supply 9 volts to these leads, if there's a problem with the power stage section, the Lynx still isn't going to power on. What you need to do is you need to bypass the power stage completely. And the easiest way to do that is actually this large capacitor right here marked C39. So if you actually solder some additional wires off of the positive and negative points of this capacitor, and then supply it with an actual 5 volts, not 9, but 5 volts, you will have bypassed the entire power regulation stage of the Lynx. And if it then powers on at that point, when you've applied 5 volts directly to that capacitor, you'll know that it's good to go, that the Lynx physically is working, and that your problem at that point is some component that's failed in the power stage section. Probably the MOSFET, or not the MOSFET, but probably the Zener. But it could be the MOSFET or those transistors. But again, just to avoid all that, we just replace them all. Okay, so before I get too more involved with this, what I should probably do is at least power this up enough to verify that I have my 5 volts before I cover this thing back up, because I do have to fold these capacitors back down. Oh, wait a minute. Huh. Boy, am I silly. I never changed these two out. Boy, I'm glad I didn't cover that up yet. All right. Yeah, we still have 2 capacitors to change out because I didn't do that. I thought it seemed like I had a few too many extra. Wow. What are these anyway? 47.6.3. Okay, so that's where the bulk of those guys went to. And I'm like, why do I still have so many of these? Well, now I know. It's okay. I still have them. Just got to pull them out of here. I need my tweezers now to get them out of the box. All right, what is this? Is this the right one? 47.6.3. This is 47.6.3. So I need one of those for sure. Probably gonna, the other one's probably the same thing. Yes, it is. I can see it. So let me just grab another one. Okay. Since they're both the same, and I've already verified that, I'll go ahead and remove both of them. Now, the reason why I have a finger on the capacitor and wiggle it as I'm desoldering it is to make sure that the solder that I am pulling up, and any that doesn't get pulled up, doesn't give the leads a chance to stick back down and basically, you know, just be a pain in the neck for me. Because that will definitely happen. They will definitely do that. All right, we're going to have to reform both of these. And they will also have to be further reformed into a 90-degree for this to lay flat. I can't remember, was this one laying flat like that? Because this one's going to have to lay like this. It'll be tight, but I think I can get them to both fit side by side. Okay. Get this one in first. Oh, wow. I just think it's funny. I'm sitting here and I'm all concerned about all this other stuff, you know, and getting ready to power this thing up, and I'm like, hey, I just realized those capacitors don't look like they've been replaced, and they had not. Yeah, they look like they hadn't been replaced because they hadn't been replaced. Well, that's why. Got to turn my temperature back up a little bit. Okay. You know, part of the reason why I arrange the caps or I replace them in kind of a circular motion around the actual board is to purposely make sure I don't forget any. And yet, somehow I still managed to do that. That's okay. I'm the one beating up myself on that one, needlessly. Okay. After I get this cap in and I verify my voltages are still good, I will probably end the video, my stream, at that point. Because what I have left to do is the LCD screen, the new LCD. But I will do that probably tomorrow. So I might live stream that. We'll see. If people seem to like this one okay, then I might just do that. Oh yeah, that's going to work really well. These are actually a lot smaller. I probably could have just probably could have stood them straight up and they might have fit. That's all right. Come on. There. Did not want to cooperate. I also have a fume extractor that I normally have turned on when I'm doing this work. I do not have it on today because if I did, you probably wouldn't be able to hear me talking. Then again, some of you may not want to hear me talking. Now that I think about it, that is a valid point. Okay, so what I am going to do to make sure this is working properly is I will go ahead and attach it to the battery leads. Let me get my bench power supply wires. Okay. And get my meter. This is an old analog. I have an old analog meter-based bench power supply. It works really, really well, but it can drift quite a bit. So it even says, I think on the bottom of the unit, on the bottom of this thing, it actually says to verify the voltage with a meter before connecting anything up. So that alone tells you that even back then, you know, they weren't too sure. Okay, so I'm going to turn this on. And we are reading 10.14 volts. Let's drop that down to about 9. That's pretty darn close. Turn off my desoldering iron. I don't think I'm going to need it anymore. Let me use my fine adjust to try and drop that down a little bit further. Oh, it's the wrong one. Here we go. 6, 5, 4, 3, 2, 9 volts. Dead on 9 volts. Or I guess I could say bang on 9 volts, right? Okay. Turn my meter back off. Cover the probes back up. Turn the meter off, or turn my multimeter off, I meant. All right. Let's hook these leads up. At least they're nicely marked as red and black, huh? It's easy. Okay, so what I'm going to just be doing here is I'm just going to be checking voltages, and I really shouldn't have turned my meter off. Let me get this solder out of the way. Kind of roll it back up there. Get these old caps out of the way. All right. Okie dokie. Let's see if I can remember where the grounds and everything are on this. It's a little wonky the way this thing's set up because the Lynx is just, it's different. All right, so we're going to power it on. Hopefully that worked. There isn't any kind of a power LED on the Lynx, which is really annoying. But yeah, there isn't. Okay, not reading anything there. Oops. Okay, probably didn't turn on yet. Let me use the little rubber buttons. I'm not really getting anything yet. I don't think there's actually a problem. It might be that I have to have more stuff connected up. I can't recall. I will take a look at it more in depth in a bit. Probably could have attached the speaker. Oh, I know. Might also. I don't think I have to have a cartridge in it, but maybe. This is a diagnostics cartridge. Okay. Turn that off for a second. That cartridge is in there. Let's disconnect these. This is the first time I've tried to use this. It's a diagnostics cartridge, but it's it is in there. Let's see. I think I have another Lynx cartridge sitting around here, possibly. Nope. All right. Well. Then I will have to go get me a different one just to make sure. Good. Might have a short because it's taking up a lot of current, which it should not be doing. Let's see. Where might that be? Let's check for some shorts. Okay. Seems normal. Let's bring it down to the 5 volts so that we don't risk anything getting juiced here. Okay. We got 5 volts. So let's go ahead and bypass the capacitor, like I was talking about before. Make sure there's not a problem in the power stage, although there shouldn't be. And let's see, I just need a couple of wires. Nothing fancy. There we go. These are roughly the same size, so they'll work. Okay. Okay, that doesn't seem to be drawing a crazy amount of current. Seems to be about correct. All right, let's see here. Let's find a ground. Imagine any of this should be ground. Okay, that's... Oh, maybe not. Maybe this whole thing is one giant positive ground plane. Really? Yeah, I'm getting negative 497, so that's... Okay. Well, that's correct. But attaching it to this section, powering it on, I think. Okay. Nothing. Slowly increase the voltage. It's close to 9 volts. There. That just kicked in. Yeah, way too much current. Something's still not right in the power stage. But I'm not sure what right offhand. So I will have to investigate that. But for now, I'm going to end it here. Been on for well over 2 hours. So that will be it for today. Thank you, everyone.